So here is our MS11E. This is our SPI system. It uses 3D dual projection Moire in order to determine if we have good solder deposition on all the pads. So we have our test board in here. I'm going to go ahead and run through this test board. And what happens is we go through each frame looking at multiple different solder depositions on the PCB, and we're looking for volume, XY offset, bridging, shape deformity, basically looking to make sure we have good solder depositions across the entire panel. Once this is done, we're going to go through and hit the review button here and look at each one of the different anomalies that the machine has presented to us. Here we're looking at a pad which doesn't have any solder on it, and as we step through the anomalies, we see that we have bridging here, bridging between pads, and we're also looking to see if we have sufficient volume. Once we collect all this information, this now becomes available to my offline PC. And that's where we're going to actually have a chance to show the operator what happened at the SPI system. And this is our MB6 Omni. This is a 3D AOI system. This machine uses a 15 megapixel camera and digital tri-frequency Moire. We have 3 different frequencies that we use to capture and profile all of the different components on the board in 3D. Tri-frequency allows us to go anywhere from 0 to 25 millimeter components in height. So what I'm going to do here is, this is our test board. We have quite a few anomalies on here, or defects, quite frankly. And what I'm going to do is go through and run it. And as I run this, we're actually we're going from frame to frame, and we're verifying whether or not the components are there. We're verifying the proper length, width, height, and also coplanarity of all of the components on the board. Once the machine has gone through, it's going to present the operator with a set of anomalies. I say anomalies because at this point, we go through and classify whether they're defects or not. So here we're going to hit the review button, and then we step through each one of the anomalies. Now at this point here, we can tell definitely that we're missing a component. So I can classify that, if I would like, down here as being missing. Now the way this works is we're also going to be presenting this information to our X-ray system. So what I want to do is I want to classify those regions of interest that I want to do an X-ray test on. That'll be post-AOI. So if I look at, for instance, there's a BGA that we have that there's a defect on. That'd be right here. So this is a BGA. Now it's a bottom terminated device. If I look at what the machine has called out, the 3D AOI is saying that this location here, that corner, is actually raised. I really can't tell what that looks like, once again, because it's a bottom terminated device, and I can't tell really what happened. Perhaps it was a process issue, perhaps there's something underneath the device. So at this point, what I'm going to do is classify this as smart loop. What that means is, now I want to be able to take that and look at that at the at-line X-ray system. And this is our offline PC on which we're running our INTELLI-TRACK software. What we've done is we've collected information from the SPI machine and from the 3D AOI machine, and we've also collected information from our at-line X-ray. And that is presented to the operator in one screenshot, which allows them to kind of figure out where the process went wrong. If you recall that BGA that we saw that was lifted, well, here we see that the X-ray system shows that there was actually an 0201 device underneath the BGA, which caused that corner to be lifted. So basically what we're showing here is our 3D SPI shows us all of the solder bumps that are there. Everything's good as far as solder goes. Our 3D AOI is showing us that that component was defective, but really we could not tell anything until we put it through the at-line X-ray to determine exactly what the root cause of the issue was. At this point here, the board would go to rework, and we would remove that device and then basically place the device down again and make sure that we can make the board work properly.